Hello, good day viewers. Welcome to another mathematics presentation. So in this presentation, we are going to look at vectors. So this is our question B right here. In the diagram below, SR is equal to A vector, OP is equal to 2B vector, and PQ is equal to 3A. The lines PS and OQ intersect at S. S is on OR such that OS is equal to 3SR. So this information when it comes to position vectors is very important. So we have this diagram right here where we have OP having 2B vector, PQ having 3A vector. Then we have the point where they have told us that OS is equal to 3SR. OS is equal to 3SR. So meaning that to find this OS is 3 times bigger than SR. So we have to multiply the 3 times the A. That means we have found OS. So let us now look at our questions. Express each of the following as simple as possible in terms of A and or B vector. So we're going to start with the first one, A or S. So they want OS. So remember, I've said the information is very important. So how can we find OS? So to find the OS, we are going to do this. We are answering for question B1. So to find OS, so this direction tells you that it's moving from the origin to the point S. So now they have given us certain information where they have said OS is equal to 3SR. So we will write this OS is equal to 3SR. Okay, so from here we are going to proceed to say OS equal to 3 times SR we have been given in the question. SR we have A vector. So where there is SR, we just put A vector. So here when you multiply, we are going to have OS equal to 3 times A vector. This will be 3A vector. So meaning that from this point up to this point, we are having 3A. So if you want to find OR, you just add the OS plus SR, meaning 3 plus 4A. We are going to have, 3A plus C, we are going to have 4A. So we have answered our question B1. So we now move on to our second question. So the second question is saying, we need to find OQ. We need to find the OQ. So where is OQ? OQ. So we have to move from point O up to, we reach to point Q. So if we want, point Q is right here. So we move from point O to point Q. So you can move OR plus RQ, or you can move OP plus PQ. So to move this side, OR, yes, you know, but RQ you don't have. So you use the direction where you have the given vector. So in this case, we can move OP plus PQ because here we have 2B and we have 3A. So here we are going to write our answer. We are finding for OQ. So here we'll say OQ. So OQ equal to, so we have said you move OP plus PQ. So remember, I've said that you can even move this side, but this side you don't have anything. So from here you say OQ equal to OP. From O to P we have 2B vector. So I write 2B vector plus then PQ. This is PQ. We have 3A vector. Make sure you follow the direction. We have 3A vector. So we write 3A vector. So this is our answer. So if you want, you can just write it in order. Okay, where we say OQ. We start with the A alphabetically, not so 3A plus 2B. So this they can mark all this. So that is our answer for OQ. So let us now look at our third question. All right, so here we have now come to our question C. We need to find QR. So where is QR? QR. So we move from Q, okay? QR. So we need to move from Q until we reach the point R. So we can move QO plus OR, or we can move QP plus PO plus OR. Now this one to be the longest side, the longest movement. So better we move QO plus OR. Why are we saying QO? Because we are just from finding OQ. We know this OQ. So if we move QO to be just against the direction, but we know we use the same answer that we got. So from here we are finding for QR. So we are now on C. So we are saying QR. So how do you move for QR? So remember the emphasis. I've said you need to move QO plus OR. So we will move QO plus OR. This is what we are going to move. Now, this movement, we will say QO, OQ. We answered this OQ, which is 3A plus 2B. Now, when we say QO, okay, it's against the direction. Okay, so what we are saying is this. We answered OQ, but it's QO. It's against the direction. So meaning that this answer, this one, we are going to multiply it with a negative. Okay, so it's a negative because it's against with the direction. 3A vector plus 2B vector cross plus OR. Now, which one is our OR? So remember here, OS. Remember what we found for OS? This is our OS, 3A. So from OS we have 3A. Again from SR we have A. So to find OR, we just add 3A plus A. This will give us 4A. So OR, we are having 4A vector. Then from this stage, what you need to do is just open the brackets by multiplying with a negative. So you say negative times 3A, you have negative 3A vector. Negative times positive 2B, you get negative 2B vector. Then plus 4A vector. Then from this stage, what are we going to do? Let us just group the like terms together. So the like terms here, we are going to have negative 3A, say negative 3A vector plus 4A vector. This one is the like term because it's having A. Then minus 2B vector. Then from here, we need just to simplify. So negative 3A plus 4A vector, this will give us A vector minus 2B vector. So this is our answer. So this is the vector for QR. This is the position vector. Okay, so we have answered our question C. I hope it's clear. We now come to our last question. So let's just look at our last question. So this is our last question. Given that OX is equal to HOQ, show that PX is equal to 2, in brackets we have H minus 1, then B vector plus 3HA. So here we just need to prove how this answer came about. So the information is very important. The first information is this one. OX is equal to HOX. So you need first to solve for this one. Okay, so how can you solve for this one? Remember, we use OX equal to HOQ. That's what we are going to use. So from here, we'll come back here. So you say we are answering for 2. So we have been told that OX is equal to OX is equal to HOQ. HOQ. This is what you have been given. So first thing, solve for this one. So you say OX equal to H. This H is just the constant value that they have introduced. So OQ, you need to get the answer for OQ that you found. So remember, we answered something for OQ, which was this one, 3A plus 2B. So this is what you put on OQ right here. We are saying H open bracket 3A vector plus 2B. So this is tricky. If you got the first vector, the second vector wrong, everything will be what? Wrong. Then from here, what are we going to do? Let us just expand. So say OX equal to, so when you are multiplying now, the constant with this constant value has to be on the middle. Okay, that's how we do it. So I say 3, then HA vector plus 2 times H times 2B, it will be 2HB vector. So this is our OX. So after finding now your OX, they said that show that Px is equal to this. So just be interested in Px, that's all. Forget about this. Px. So just write Px. Now you need to prove it. So just write, you say Px. So Px equal to, then you go back to your diagram. So this is your diagram. Identify where is Px. Px. So to find Px, you can move PQ plus OX. Sorry, QX. Or you can move PO plus OX. Now, the best movement will be PO plus OX. Why? Remember, in this statement, they gave you OX. So that's why we move this PO OX. Because OX, we have it right here. Okay? So, that's what we are going to move. We say PO plus OX. Now, PO, it's against the direction. So, this will be a negative 2B. Okay, OP is 2B, but PO, it will be negative 2B. So we will say, we move like this, just like I've explained. So here, we will say PO plus OX. So from here, what are we going to do? We'll say PX equal to, so I do hope that you are following. PO, I said is against the direction, so it will be negative 2B vector, like this. Then plus OX, this is the OX you answered on top right here. So just write it, 3HA vector plus 2HB vector. Now, group the like terms together. You can see here you have negative 2B, there is a B. Even here you have 2HB, there is a B. So let this one go this side. So we are going to have something like this. Px equal to positive 2HB minus this 2B vector, then plus 3HA. So for this one, doesn't have its like term. Now here, what you do is, you say Px equal to, the numbers are common here. In terms of the numbers, they are common. You focus on these two. The numbers are common. So you factor out the number in front here, open bracket, again open bracket. In terms of the letters, we have B and B. So the B, you put it right here. Okay? So if you remove the 2 here, you remove the B here, you remain with the H. Minus the 2 is here, the B is there. So 2B is outside. So 2B into this 2B, you remain with the a 1. Then plus 3HA vector. So if you observe, you compare with this one, 2H minus 1 in brackets B plus 3HA. So with what we have gotten, okay, you can see that it's actually the same. Okay, 2H minus 1, then B plus 3H. So it means you have proven. You just say, hence shown. This is your answer. And you'll be given the 2 marks. Okay, so we've now come to the end of our session. Thank you so much, everybody, for having time to view this content. This has been your presenter, Mr. Mlenga. Bye-bye.